Right. Hello, everyone. Hello, everyone.
Hello there. Hello, Justin. Hello, Paul.
So, welcome to the great .NET 8 hack. So
Yay.
we so we have started this .NET hackathon from November 20th, and we'll finish on December the 4th. So today we are running a cloud native session, how to build a cloud native application with .NET 8 and Azure. And I have these awesome colleagues. Hello, George, and Paul. How are you doing?
Doing very well. Thank you.
Hello. Yes.
Hello,
So excited to
everyone.
be here today. I should say this. 안녕하세요, Justin.
Oh, that's nice Korean. So you are a Korean descent. So
Yep.
yeah. So would you please introduce yourselves from George, please?
Yeah, I'm a cloud developer advocate on the cloud native team. We work with the Azure Kubernetes service and also with Azure Container Apps. And yeah, we're promoting, we're helping to create content, work with the community. We present at conference. That's pretty much what a cloud advocate does. And you, Paul?
Yeah. Hi, everybody. My name is Paul Yu. I am also a developer advocate on the cloud native team here at Microsoft. I'm actually a teammate of George. And so I focus on cloud native, but mostly Kubernetes and AKS and everything around the cloud native ecosystem, which is a lot. So yeah, happy to be here.
Wow. So my name is Justin from Microsoft as a senior cloud advocate, and I am in .NET and Azure team. So I'm mostly talking about .NET stuff and Azure stuff. So we are working together with I'm working with together with George and Paul about the cloud native stuff. Right. By the way, we all live in different continents. So Paul,
Yeah.
you live in LA, right?
I am in LA.
Yeah.
Yes.
And George, you live in Melbourne, Australia.
I'm
Right.
in Melbourne, Australia.
Yeah.
Yes.
And I live in Daegu, South Korea. So we are in the
Three
same
different-
cloud advocacy team,
Mm-hmm.
but we all live in different continents and even different time zone as well. So
Oh, yeah.
yeah. So we all like the conversation
We're all-
usually take Oh,
yeah,
so
we're
sorry
all
about that.
distributed.
Yeah, that's the main differences. So our conversation usually takes place in the asynchronous way.
Mm-hmm.
Exactly.
Yeah.
And all remote work and asynchronous.
But it's efficient for us, but sometimes it's difficult to tracking, right?
Mm-hmm. Yeah.
So I think it's similar to our cloud native application development. So
Yeah.
Paul, I have a question. So I
Mhm.
just said I'm the cloud native. So what's
Yeah.
exactly cloud native?
Yeah.
Can you explain more about the concept?
Cloud native almost seems like a nebulous term these days, but essentially, cloud native is an approach to building your application, packaging your application, shipping your application, and monitoring it all with the cloud in mind. And that could be in a public cloud, it could be private cloud, it could be even in your own local data center. The point is that your application is built in a way that you can easily deploy because it's all microservices. The infrastructure, they're all API driven declarative infrastructure, and observability is a huge part of that, and so is scalability. So cloud native is basically building with the cloud in mind and making sure that your application is scalable and resilient to all that. So
right. And for the cloud native stuff, so we usually rely on the containers, doesn't it?
typically it is containers. It's not all about containers, but it is mostly containers.
All right. So
Yeah.
this really because I'm not kind of the container person. Containers, usually I use container for developer container, like GitHub code space or something like that.
Yeah.
That's the most use cases for that. But nowadays everything looks like we have to make use of containers for our application development. Like George. So
I know what
back in
he's
our
coming
days
from,
when
I
we
know.
worked together before Microsoft. So we used to have some kind of funny debates at the pub while I'm drinking beers or something like that about the containers versus serverless whatsoever, right? So can you introduce that kind of episode?
Yeah, funny that I think a few years ago we beginning of serverless and containers. I think Justin went for the servlet side. I went for the container side, and now we sketching together now after a few years, and those things kind of combining and become one thing. You're going to see like Azure Container Apps become like kind of a serverless platform, and how they come together after a few years. And I don't think it's one or not anymore. Just in how it used to be, our discussion is now, one plus another and become something else. You can use both. What do you think?
Yeah, yeah, that's really the correct. So I was kind of the strong opinion and the serverless, but nowadays, should I? No, but anyway,
that's so funny.
yeah.
Were they heated debates or friendly debates? I would imagine if you're in a pub, they would be pretty friendly and casual.
Yeah, indeed.
Yeah.
So, but nowadays, the more and more applications are developed and deployed into like the containers or using containers or something like that. It's called cloud native way. So let's start the something again. So focus on our session that okay, .NET in cloud native way. So how do we use .NET in the cloud native landscape? So we've been working really hard to put so many good things on for the developers for use, like the health check endpoint or Kestrel server or HTTP client factory or gRPC or the container builds or native AOT, these kind of all good stuff. And these are just the examples, not that all. Most frequent feedback we received from the community was like this. So I've got so many good things, but I'm not sure how to put them all together properly or correctly. What they say is that I just want to put everything together without hassles. So let's think about this. The common questions are like this. How to get my web application to talk to my backend API application? What should I do with development and production configurations? And what should I do or what shouldn't I do? Use containers. And what should I do with end-to-end logging and monitoring stuff? So these are things they are always asking to each other, and these are the common questions building the cloud native application. So after all of this, that's not fun. So I don't like it. So it's not fun working with all of these stuff by myself. So that's here's Aspire for the rescue. So that's why we introduced .NET Aspire for this kind of specific problems. So let's think about this simple scenario to put a Redis cache into your front-end web application in .NET application development. So at the very beginning, we need to add a NuGet package called stackexchange.redis. Then we need to add whether that Redis cache container is working properly or not. So we need to check that. So we need to add health check and the package as well. So ASP.NET Core, health check, Redis NuGet package as well. Then once we add these kind of things, then we need to write our dependency injection this stuff and configure these kind of the connection strings from app settings.json. And we need to add the Redis health check, the endpoint, for the availability. And we also need to like the Redis client output logging to iLogger as well to check the monitoring, and all do the plumbing stuff for the Redis client and event profilers for the metrics stuff. And finally, we need to wrap these Redis client with resiliency policies and something like that. So whether that goes the unhealthy or that goes healthy, we need to double check everything. So these are things we need to manually add in the program.cs or something else, right? And that actually lead to confusion or frustration because there are too many bits and pieces to take care of for us. So if we use Arteiro, the component, the Arteiro Redis cache component to the web application, then that the large portion of process and the plumbing process will be reduced, significantly reduced into just two steps. The first one is the add the NuGet package called aspire.stackexchange.redis.output caching. This is the one package we need to add. And finally, we just add the program.cs file to add this line, the builder.add redis output cache. That's it. Then if we need to some more like a granular control, then we need to put some additional configuration onto the app settings.json, but that's optional. So basically, we have two lines of the code. Now, it actually reduces a significant number of effort from ourselves. So that is really great for us. So what is standard Arteiro? So standard Arteiro is kind of an opinionated and cloud-ready stack. So with this Arteiro, we can build observable and production-ready and distributed applications. And then .NET Arteiro is delivered through a collection of NuGet packages. So it's not just one package; it's the collection of all the NuGet packages that handles specific cloud-native concerns. The Redis cache is just one component of the entire Arteiro NuGet packages. So the .NET Arteiro provides us with three different features. The first one is orchestration. With this orchestration, we can run and connect multi-project applications and dependencies in one the project. So we don't have to worry about all the projects need to be connected properly or not, because the orchestration does everything for us. And the second one is component. The component is actually consists of different the collection of NuGet packages, such as the Redis cache or something like that. So NuGet packages with standardized interfaces. So all we need is to put builder that add something. That's all. And tooling. The third feature is the tooling. So with this tool, that tool helps us to create and interact with .NET Arteiro applications. So these are three main features of using .NET Arteiro. So sounds like, as I said, it's opinionated and the libraries, collection of libraries. So you don't have to follow this the practice, but with this Arteiro, we can provide you with the very you can significantly reduce number of the steps or effort to build the cloud native applications. So if you download .NET 8 with a .NET Arteiro workload, and you will be able to create two .NET Arteiro projects. One is .NET Arteiro, the very basic project, and the other one is .NET Arteiro startup project. So with this .NET Arteiro startup project, you will have these two applications, basically. So first one is web application, is built in Blazor, and API application with ASP.NET Core Web API. So these are the typical front-end application and back-end application. Now, in addition to these the applications, .NET Arteiro adds these two additional projects. One is app host project, which is taking care of all the orchestration stuff, and service default project, which is provide us with extension method for like the service discovery or the resiliency, all kind of stuff. So with these two app host and service default projects, this web app and as the backend API app works seamlessly together. We don't have to worry about anything. Now, my talk is too far, too many. So let's build a simple demo with ASP.NET. The .NET Aspire project. So I'm going to start with existing Blazor web application and API application. Then I will add Aspire orchestration. Then I will add Redis cache to the web application side. Then I will update resiliency settings. And then I will add the asynchronous pattern using Azure Queue and the table storage. And finally, I will deploy this Aspire application to Azure using Azure Container Apps. Right. So let's get back to where is my so Visual Studio. That's my Visual Studio now. So I have basically the API application and web application, which is the Blazor application. So I'm going to run this application. Where is okay? So I'm going to run this application. So if I click this application, so I'm going to just show you how it is running. So that's something now currently being built. So with this application, so once it is built and the up and running, we will be able to see two web applications, which is Blazor and API, the ASP.NET Core Web API. So it takes time to build these kind of things. So so what it does is that this web application takes the YouTube URL and YouTube video URL. Then it takes all the subtitles from all the captions from the YouTube video, then summarize it into a designated language, which is maybe English or maybe Korean or something like that. So let's take a look. So how it's going. So okay, my application is being built now. It takes time. Is it because my machine is so slow? Okay. So okay, here we go. Now, is it running? Not yet. I don't know. Okay. So come here. So it now come here. Okay. It now come here. Now, so this is a web application. And now I have like the typical weather, the application. So it just the similar, the typical that's the Blazor start included in Blazor start application. And this is the summary. And if I put a YouTube video, that's so this is some YouTube video that is something like was done in the .NET conference last week. So if I put this URL into there, then this is definitely running in the English, and this is a summary language in English, either or Korean. So I will just choose English for now. So then, oops, oh, I don't have an endpoint. Okay, that's okay. I will put the endpoint. I will put the endpoint. Where is my endpoint? Okay. So I'll put my endpoint. Then, okay. So it happens. So it just takes more time. So anyway, so that's what it does. So once I put the application in there, then it comes. Okay, come on. So it comes with other. Here we go. So if I put this one, oops, not this one. Where is my YouTube video? Then it will summarize, it will bring us a summary of that video. So once it's done, it's fine. So that's the current existing applications. So that's like this, right? So I will then as I showed you before, I got an error, right? So I got an error because I have to add these the endpoint to web API, these the configuration settings. But let's think about this. If I have more API, backend APIs, and my front-end application need to talk to more than one APIs at the same time, then I have to configure these kind of things individually. And that's a different component, web application component and API, backend API component. If there are more than that, then we have to configure everything individually. That's something we don't want to use. So here is where the .NET Aspire comes in. So in this case, I will add the API app. So I will add here. There is some .NET Aspire component and .NET Aspire orchestrator support. So I will choose orchestrator support. Then it will have okay. So I'm going to delete. Something because something has already come here. So okay. So I'm going to add orchestrator support. Then it will create app.host.cs project file and service default CS project file. So just click in here. Then it has app.host file. Okay. So it's done. Now I also put another orchestrator to web application side as well. So once it's done, so it's all done. So in here at the host file, I have, so this is the orchestrator file. Then so I have this web API, and within the app host file, which is the orchestrator project, it has a web application and it has API application as a reference. And within here, that program files, it has these references. So I will just simply change the name because it's too long. And here is a bar API app, like this. And then this API app is configured into with reference API app. Like that. And by doing so, within the app host project, which is an orchestration project, by doing so, we just simply connect these two projects without knowing anything, like this. Now, within the API application, we have this one. We have this the connection string, but we don't need this part any longer. So we just changed into this part. So we just simply change the app settings file from API application to app host orchestrator. Then we need to add it to that part. So let's get open AI settings, the configuration, open AI settings name. I guess there, and then there. So we have OpenAI settings. Then we can add with environment OpenAI settings and AI settings endpoint. Then endpoint API key deployment ID And simply I just copy these things into here, here, and here, and copy this API key, ID, and this. So what I just did is that I read the app settings file from the app host project and add this value into the environment, because I use this part. So OpenAI two underscores with endpoint API key deployment ID. That's how we read and the endpoint environment like this. So once I did, I removed this application, the OpenAI settings from API project, right? API project. But I added this the API settings into the orchestration project. Then it will be passed from the orchestration, like passed into the from the orchestrator project to the API application like this. So by doing so, I can just simply add. So I can run this application like this. Then once it's added, see how it's going. So if I run this application like this, so I have the summarizer dashboard application because I just added Aspire project. And when I run this the Aspire application, then it firstly comes with this Aspire dashboard project. And then it shows us there is the front-end application here, and there is backend application here, like this. So if I click this application, then we can see that, right? And then we can see the weather, and we can just check it like this, okay? So then we go back to the dashboard here, and we have all the log file, data come here. And web application, we have this log file. And these are all connected together because we can see the traces here. And oops, not this project, traces here. Oh, it doesn't come in yet. Okay, that's fine. So, now I understand because I didn't put something else in here. Okay, so this is how the Aspire the project looks like. Now, so I put this. So I configured this one working fine. Now, this is how Aspire works. Now, I want to add. I want to add the Redis cache because so if I click this weather here, then it keeps changing. But I want to keep like the same data for 5 seconds. Then when it keeps data for 5 seconds, then it changes again, something like that. So I will, by doing so, so how can I do this? So I will put the Redis cache to the web API, the web front-end application as well. So I will start this application. Then I will put the I will change back to the API application like this. Now we have Aspire. So we have Aspire and Service Depot project, and now we have web application. Now I will change this into starter project, and here in the web application, I need to add component, then the Aspire component for Redis cache. So let's check out the what is available. Now we have Aspire Stack Exchange Redis, and we have Stack Exchange Redis out caching. So I'm going to add this into here. Then with this the component addition to the web application project, and it will update something like this. So we have program files here, and we have service depot, and we have the web default endpoint, right? And that's something add into the here as well. So we don't have the service depot here. We have with the service the default, we have the web default endpoint, right? So these are actually connected to how on the app host app host project for the Aspire integration. Now, but we need to add one more thing to the app host here, because we just added the Redis cache project, but we don't know yet. So I'm going to add cache and builder add Redis container, say cache, something like this, and then we just simply add reference to cache. Okay, like this. By doing so, we just add Redis container to we just added Redis container, and it is connected to the web application front-end project. Now, and then where is this API at? And this is a web application. So under this app service default, and I'm going to add builder, add Redis out cache, something like this, and the name is cache. Okay. So this is how we add Redis out cache. So with this line, we just tell the application that we are going to use the Redis out cache, and the everything else you need to do. You need to take care of the rest. That's what we do like this. Now, once it's done, then we need to update. We need to update our web application page. Where is my page? Where is my page? Here in the weather, here. So I'm going to add this out caching. Yeah, and I'm going to add the cache duration. Yeah, like this. So that means we are using the Redis out cache for 5 seconds, something like this. So once it's done, then let's run this application again. Then it will do it will apply the Redis cache for output. So let's wait a few more seconds. Then it will the project will be up and running. Yeah. So that's how we can add the Aspire. We can add Redis cache output to the Aspire project without having to change having to configure many things on our applications. We just simply add reference, add the Aspire package, and then simply add a few lines of it. Now, so we have this Aspire package, and now we have the web application like this. Then now it is the 2 seconds, and it keeps changing. Why is it? What did I miss? What did I miss? Okay, so by doing so, then I have another one add here. Okay, so that's I already built the Redis cache. I think that's pretty much the same. But let's I think it doesn't change anything. But why doesn't it working? Okay, that happens. That sometimes happens. So let's run this application again. Yeah. So once the application is up and running, so let's check out our pages as well. So I think it should be working fine this time. Maybe I didn't compile the build application much. Okay. Now, okay. Now you see that? See if I even click that, then after 5 seconds it changes. After 5 seconds it changes. So what we can see here, then we have the log here, and API doesn't have much things, even if I click means time. So if I see the trace page here, so first of all, if I check that here, so the front-end application hits the API page, then gets the API response from there. Then it is set to the Redis, stored into Redis cache. So if I go back to the next request, it only hits the Redis cache rather than the continuously hitting the API application like this. So, but what I did is just add Redis cache container. I mean, Redis cache Aspire packages, and that's all about it. So this is how we are working like this. Now, I think I have spent too much time. So this is how we are our application is working running. So so I'm going to skip all the rest stuff because I need to I have spent a lot of times. So then if I put I have put all the resiliency, and I have put the asynchronous and the Azure queue storage and table storage stuff, but it takes the more time, so I don't spend more time for the rest of the time. So I will just change a little bit here. So I put this the application into our GitHub repository. Then I will change a little bit on the site, and so that I can deploy this application directly on Azure using CI/CD pipeline. So if I just simply change the README document, then it will execute the trigger. It will trigger the GitHub actions. Then once it's done, it will be deployed into Azure the container apps. So this is the Azure container apps environment like this. Okay, so here we go. So we have the containers like this. So we have web application for container in the container. We have API application in the container. We have cache, Redis cache container. So these are all connected together, right? So in here, we haven't published our dashboard because dashboard itself is only for your local development for monitoring. But once it is deployed to Azure container apps, but still they are connected together because that orchestration is doing all the plumbing things for us. Okay, so this is how we deploy the application to Azure using the GitHub Actions workflow. But later of this session, we are going to use AZD, Azure Developer CLI. So we will touch this later. But for now, I deployed into the Azure container apps. But for me, as I mentioned earlier in the beginning, so I'm more a serverless person. So I have no idea what the container apps looks like. So I will ask George. George, are you ready for explaining the Azure container apps and the Azure container services, Kubernetes services?
Yes, I am. Let's go. Let's do it. Thanks for the nice introduction on the Aspire components, orchestration, and tooling. And yeah, after having seen all these things, and it's nice that Aspire is a we coming from another project called Project TIE, and that's the second round of improvements, and now became Project Aspire. And on the cloud native, it's very important for us to have these components. I compare that a lot with DEPA, CNCF DEPA that was donated by Microsoft to CNCF. We're going to talk a little bit about that. And on the cloud native space, we have those two main services, Azure Container Apps and Azure Kubernetes Service. And they basically are inside these application platforms inside Azure. As you can see, Justin was talking about Redis cache, but we have Azure Kubernetes Service, Azure Container Apps, and also Azure Functions. Remember the discussion that I had with Justin about serverless coming together with containers? I think that's where they are sitting together now. And all the goodies, API management, database, storage, and all the CNCF open source ecosystem now that we have on Azure, Prometheus, Grafana dashboards. And we're going to talk a little bit about these two projects, DEPA and CADA as well, because they are the foundation of the Azure Container Apps. And if we try to see the difference between Azure Container Apps and Azure Kubernetes Service, you're going to see that Azure Container Apps was built on top of the Azure Kubernetes Service, means that it's kind of a control plane for Azure Kubernetes Service, where we can bring some things and it'll be more flexibility, time to market. You can even scale that to 0, something that you cannot really do on Azure Kubernetes Service. You still have to maintain one node pool to be able to run the cluster. On Azure Container Apps, you'll be able to fully scale to 0 and don't pay anything. On Azure Kubernetes Service, you can scale the application node pools to 0, but not the system node pool that manage, the cluster components that you have installed on the cluster. Another thing is the same way that on Azure Kubernetes Service, you have full control on the customizations. You can install any plugin, anything from the CNCF runs on Azure Kubernetes Service, but still a fully managed Kubernetes service there. On the other side, Azure Container Apps is easier, for the apps, for the developers, as you can see that integration with Aspire now. And following my presentation, you're going to see a demo from Paul, how to use that and quickly deploy on Azure Container Apps as well, and on Kubernetes Service. Then, coming on that simplicity, we can say that like Azure Container Apps is kind of the serverless platform for containers. The only thing that you need the container to run your application means that you have to build the container image and you have to deploy on Azure Container Apps. That's what Justin was doing, and his workflow you can see on the GitHub, this GitHub there, that he was building. And now with .NET, I think 7, now .NET 8, you don't even need a Docker file to build a Docker image. You can build from the source code. The .NET 8 SDK now is able to publish your application as a container without even we know what Docker file is. And those both services, they can run, they can have DEPA and KDA projects that I was talking about, and we're going to see what those projects means. And they can run any language that you can pack as a packet or as a container, we can deploy on these service. The difference is that on Azure Kubernetes Service, you have full access to the Kubernetes API. Kubernetes is a Cloud Native Complete Foundation project. It means that having full access to the API, you can do whatever you want. You can bring different kind of storage, service mesh. You can install any product that depends on full Kubernetes API. And then let's see a little bit how people are using Azure Container Apps. Those are the main use case for Azure Container Apps that basically work with microservice, that microservice communication. When we deploy Azure Container Apps, we have what we call environment. Environment is a place where you can deploy multiple applications, very similar with like app service environment idea. We have that plane or that environment where you have networking. You can talk with HTTP, TCP connections, gRPC, and you can deploy that Microsoft architecture, and that's where the DEPA project helps a lot. And also you have like revisions, similar to app service, where you can deploy slots. You can compare revision with slots. You can have multiple revisions, and you can even split the traffic between those revisions. Let's say you deploy version 2, and you just want to do like a canary deployment and have like 20% of the traffic until you're happy with version 2, and then you can move all the traffic to version 2. And then you still can do full web app application, event-driven, and backgrounding process. And on the backgrounding process, that's why we come into something like KDA. KDA is outscaling, where you can scale your application based on those metrics, on those called scalars. And a scalar could be like a message queue. Imagine that if you have more than 100 messages on the queue, you want a second instance of your microservice to be able to process those messages on the queue. At the same time, if your messages go down to 0, you want to scale to 0 and don't pay anything. And just I hope you're happy. Now we have serverless and containers together, scaling to 0, and that's what the magic that KDA can do. And the same thing with DEPA. And I recommend you to look on the Aspire samples. There is a sample using DEPA with Aspire, have a look there, and you can bring all those components from DEPA. That's something that Aspire is trying to bring as well, but we have this done already on DEPA, and you can bring the whole DEPA ecosystem together with Aspire, and you can check on the demos. And DEPA is pretty much like a components as well. We can connect with your application for service-to-service invocation, state management, pub/sub, observability, some things that we have on Aspire, but you can have also with DEPA, and you can integrate if you're already using DEPA. But what's AKS now? What's the full AKS? AKS is like a full cluster of a control plane and agent nodes. But with AKS, we have a fully managed control plane that have SLA. You don't even have a free tier for that, where you can just make sure that you deploy your agent pools to deploy your application, and you can have all that extensibility that is provided by the full AKS product. And that brings things like you can have different node pools for different technology or platforms like Linux, Windows. You cannot have these on Azure Container Apps yet, like you don't have Windows on Azure Container Apps. But if you want to run, Windows applications or WebAssembly, isolated, confidential GPUs and ARM64, then you can do this all together on AKS. Azure Container Apps are bringing some of those things. And you can also integrate AKS with what we call Azure Container Instance. That's the serverless side of AKS, where you can run things outside the cluster, and you just pay, per CPU and memory. That's what we call Azure Container Instance integration. And you can call these and you can create those instances from Azure Kubernetes Service as well. If you want to learn more, those are the links for the Azure Kubernetes Service. We're going to call Paul very soon for the demo, and then I recommend you go for learning. There's a lot of Kubernetes learning modules, and also for the Azure Container Apps, the modules and the aka.ms Container Apps link, you can find pretty much all the other links there. Paul, I think people want to see this running, the demo there. Go for it. That's yours now.
Yeah. That's a great overview of Azure Container Apps versus AKS, and it's always a question that comes up too. I get asked a lot, like, well, what technology they should choose. I always say, if you're just getting started, use ACA. Once you get to the point where you really need Kubernetes API and things like that, then you can start using AKS and Kubernetes and all that stuff. But yeah, let's go ahead and jump into a demo and show you how you can actually deploy your Aspire.NET applications right into Azure Container Apps, all using, I want to say like 2 commands. So I'll show you that. And we're going to use 2 commands using the Azure Developer CLI. And if you haven't heard or seen the Azure Developer CLI, I'll give you a quick tour of it. You can Google search or Bing search Azure Developer CLI. It should take you, or you should have a link somewhere near the top that'll take you to this page right here, the What is Azure Developer CLI. It's basically a command line interface that you can use as a developer to deploy all of your applications into Azure. Why? Well, it's because as a developer, when I first started with Azure, I was a .NET developer for many years, and it took a little while for me to wrap my head around Azure, know all the different components that need to go into my deployment. I'm used to .NET Run, right? Just having it all running in my local machine. And so Azure Developer CLI aims to give you a similar experience, AZD up and deploy everything up into Azure, right? And so it enables you to just streamline the process of going from, hey, it works on my machine, to, hey, it now works in Azure and all over the world, essentially, right? So first thing you need to do is install the Azure Developer CLI Toolkit, and that's available on Windows, Mac, Linux. I'm on my Ubuntu machine today, and so it's installed here. And then from there, you can run an AZD init to basically create the azd project, and then azd up. And that command, what it does is it does three things for you. It packages your application into containers. It provisions the infrastructure that you need in Azure. And there are templates for this, and I'll show you in a second, but there's a ton of templates that you can actually just pull down and download. But it has all of the infrastructure as code, or IAC, right, that you can use to provision your Azure resources. And it supports Azure Bicep, which is Azure's domain specific language for declaring your Azure infrastructure. Or if you're a Terraform shop, it also supports Terraform now too, which is really cool. I myself am a Terraform person, and so I was really happy to see that there. The last thing it does is azd deploy, which is then packaged, or actually it just deploys the containers into your application environment. So let's go ahead and do that. So before that, let me show you this real quick. If you just do a quick search, Bing, Google search, whatever, just type in awesome azd, it'll take you to this pretty cool or awesome landing page here. And you can see all the different templates that's available. So if you are .NET developer, Python, Node, doesn't matter. You can actually filter for all these project types. So I'll just, we're in a .NET hack, so I'll just click on that. And let's say I want to do deploy into either Azure Container Apps or Azure Kubernetes Services. You can see we filtered down to a couple of these deployments. Actually, this is an and, it's not an or. So let's see, I'll uncheck Kubernetes, and then you'll see a little bit more for container apps. And then there are a few for Kubernetes. So let's go ahead and deploy an Aspire app and show you how easy it is to get it to the cloud. So let's see. What I will do here is I'll use that starter app. So in Justin's slides, you were showing the Aspire sample app, right? That has all the things that you need to kind of just get going. And so what I'll do is I'll run this command, which is .NET new Aspire starter. And let me back that up a little bit. You do need .NET 8, and you do need to install the Aspire workload for you to do this all in command line. I know Justin was doing it in Visual Studio proper, I should say. I'll be working in, I'll just be working it with the .NET CLI and maybe jump into the VS Code editor. So, I mean, you can do this cross-platform, which is like, that's probably the most inspiring thing that I saw out of .NET over all these years, is how you can just do this on all sorts of different platforms nowadays. So here, we're going to do a .NET new Aspire starter, and we're going to drop in a Redis cache, and we're just going to give it a name, right? So that doesn't really matter. So the name could be anything. So I'll go ahead and create that .NET project, and I am now in the directory. And if I just clear that, you can see here that it basically has all the things. So it has the API service to get the weather data. It has that app host that we were talking about, that orchestrator, and then it has the service defaults. This enables you to configure your application. And then, of course, we have the Blazor web application, right? So all that is in there, and it's pretty cool. I can literally do a .NET, .NET run. And if I just run that app host again, we can see the exact same thing that Justin was showing earlier. So, right? So here's the dashboard. We have our two projects, and there we go, right? Works on my machine. Lovely. So we don't want our applications to only run on your machine. We want to run it in the cloud and share it with the world, right? So let's go ahead and do that. So what I'll do is I'll drop out of here, and what I'll do is I'll run a azd init. Remember, I said there's going to be two commands. Okay. Azd init. There's some magic with this azd init command. It's going to look into your directory. It's going to detect what sort of application is in there, and it's eventually going to find that there's an app host in there. And it's going to say, oh, there's an app host. Oh, this is an Aspire app. Let me run through my special integration logic that's in AZD. And right now it's all tightly integrated with ACA. I'll show you a GitHub issue where the community is actually working right now to get it working with AKS. But for right now, it works really well with ACA, or Azure Container Apps. So it's asking me, hey, where do you want to initialize this app? I want to do it in the current directory. So we'll go ahead and do that. It's going to scan that directory, like I mentioned, and it's going to say, hey, we found this. We found the app host, and it looks like an Aspire application. Would you like to deploy it to Azure Container Apps? And you say, yeah, I do. So I'll confirm that. And the next thing it asks you is, hey, based on your app host, we found 2 web applications. One is an API service, the other one's a web front end. Which one do you want to enable or expose to the internet? We only want to expose the web front end because the API service, it's on the back end. And so we don't want to expose that. So I'll just select the web front end. And now it's asking me to enter a new name. The name is more AZD specific. It doesn't really, well, it's AZD and Azure specific. So the name that you put in here is eventually going to be the name of your Azure resource group. So I'll just say, what's a good name? Aspire sample. I'm not very creative today. So we'll do that. That's all it did. It generated some files for us. Now let's open this up in code and see what this looks like. So what we got here is, number one, we have a azure.yaml file. So AZD detected app host, and that's all it needs. And then from there, AZD, like I said, there's some integration points where it knows how to package the API service and the web application and deploy all those as a container, right? And so what we need to do here is, there's one more thing that we can do is AZD up. AZD up will actually deploy all of our resources into Azure, package the containers, and then deploy the application there. Now, there's some magic here. And what you can do is the bicep template that AZD up will run, it's all stored in memory. If you like to keep all your infrastructure as code inside of your repo, you can actually run the infra synth or infra synthesize, and you can run that command, and it'll actually save the manifest or the bicep templates into your application. So, oops, I forgot to do this. So what you need to do is you actually need to turn on this configuration. So it basically just yelled at me and says, nope, can't do that. We need this alpha infrasynth on. So let me go ahead and turn that on. Okay. And then I'll just run my infrasynth again and just watch my folders and you'll see magic happen. Boom. Now I have an infra folder. And now I have some, if I can close this, now I have a bunch of Azure Bicep. So this is the main entry point. If I go to resources, you'll see that all the Azure Bicep is here. So everything to create your container registry, do role assignments, create your your Azure Monitor workspace, your container app environment that George was talking about. So all that stuff is here, and it was all generated by AZD. Okay. Now, you could have just run AZD up, but I just wanted to show you what that bicep looked like, because it takes a little bit to write that stuff out, and it's pretty cool to see that it just magically created all that. So now when you run AZD up, it's basically going to deploy all those resources into Azure. Okay. Now we could sit here and we could watch it if you have like 6 minutes to kill, but we don't have that kind of time. We're going to go cooking show on you, and we'll show you what this looks like on the other end of it. So here, I basically deployed all this stuff just a little bit before the live stream started. And look at all the resources that you get over here, right? So we're getting the container registry. We're getting the log analytics workspace. We're getting some role-based access control configured, because all that stuff is kind of difficult, especially if you're getting started with Azure. And so just having a command like this is pretty sweet. Remember how I said that app host file? Let me show you one more thing. So while this is going, .NET run. this is where the magic of app host lies. Okay. So what you can do is you can actually run, you can do a .NET run, and you can have it publish the manifest. Aspire will generate a special manifest that kind of tells you all of the underlying, I will call it infra, but like the dependencies of your application. And so what I did was I just outputted this into a manifest.json file. And if I cat this out, if I could copy it, I'll copy it. There. I can do a cat. And you can see it's just one big JSON file. But inside the JSON file, it says that I need a cache, a Redis cache. And then it has information about my API service, all of the environment variables that would need to go into this application. For here in this case is OpenTelemetry. And then it has information around bindings, right? Same for the front end. So it talks about all the different environment variables I would need there, and then the bindings, of course, there. And so that's how AZD is able to understand that I'm going to need a cache container app, I'm going to need an API service container app, and then a web front end, right? And it configures all that stuff for you. So if I just click into the API service and go to containers, go to environment variables, you'll see all this stuff here. And you can explore all the other containers as well. So let's see what we get. And it's not that fancy because we saw it all locally. So if I go to my front end container app, remember, we enabled or we expose only the front end. And so I can click this URL and you can see you get like this gobbledygook URL. So it's web front end .wonderfulwater. I like that name. And then some names and, you know, some numbers at the end and a region, but you can click on that. And there we go. We have our application. And so now it's all running on Azure. And it's, if we waited, it would have took like 6 minutes to do, all using a single AZD init or two, AZD init and the AZD up command, which I think is just magic. So click over here. I just want to show you one more thing here. When you go to the API service, remember, this is not exposed to the internet. And so you'll see that the URL here is a little bit different. It says API service.internal. And so it can only be accessed from within the container app environment. So that's a pretty neat feature of that. So the next thing that I wanted to show you is, let's say you want to use AZD for AKS. Well, you could use that, not for Aspire yet, though. There's some work going on right now as we speak. So the story is being written as we speak, and I'm going to share this with you here. Aspire is relatively new, right? When was it released, Justin?
It was released last week at .NET conference.
Last week. That's how new it is. So as soon as it released last week, somebody out in the community says, hey, we need support for Kubernetes, right? And so
that's really awesome.
Yeah. So this issue is out there floating around, and there's a community member down here, and you can see David Fowler is all in here. So he's all over it. But there's a community member that actually wrote this, or you just spiking out a project to see how we can go from that manifest, you know, that Aspire manifest into Kubernetes manifest. And so shout out to Prometheus 5. He's been doing a lot of work kind of spiking this stuff out. And so this story is evolving like day by day. So if you're interested in getting involved in this sort of project, if you have Kubernetes, any sort of Kubernetes background, and you want to just see this unfold and see how the story unfolds, just go ahead and follow this issue because there's some pretty cool stuff happening over here. Now, how can we use AZD for Kubernetes? Well, we can't quite do it with Aspire just yet. Like I said, it's being worked on. But what you can do is, if you have a project, not an Aspire project, just any other .NET project or whatever project, you can actually also use AZD init to initialize your projects, right? Remember I showed you, where is that? Remember I showed you this awesome AZD website? So I'll just uncheck .NET just to see what kind of stuff we have for AKS. So with AKS, there's actually folks in the community. I mean, you could write your own AZD templates and actually submit it and have it showing up on this awesome AZD website. And so this was actually developed by Ahmed Sabor, who's actually on the AKS product team. And what you can do is you can actually literally copy this command right here. And if I jump back over to my terminal, what you can do is, let's see, I'm going to make a new app called AZD to AKS. Okay, so that AZD init command, it changes just slightly. What you can do is you can actually pass in the template name. And the template name is just the GitHub handle and then whatever the GitHub repo is. So you can kind of do that. It'll download. Yeah, I'll just give it a name. And if I open this up in code, look at what we have here. We have our infra folder because that's part of the template. And we can see here that we have now a bicep template. And this bicep template deploys everything that we would need for AKS. So container registry, AKS, RBAC permissions, monitoring, Prometheus, Grafana. This thing is pretty loaded. And so this is all within Azure Bicep, right? Now, last thing I want to show you before we end is, let's say you don't really know Bicep, because somebody's going to have to, either you're going to start with the AZD template, or you're going to have to write some of this stuff yourself. And let's just say you're not really familiar with Bicep, you're more of a Terraform person. You can actually use Terraform. I think I mentioned that earlier. And literally all you need to do is in your Azure.yaml manifest, all you need to do is just flip this little switch here. I call it the proverbial switch. Is you just need to add this little infra element and then put provider Terraform. And then from there, AZD just knows that you're going to run Terraform to do your deployment. And so all you need to do is in your infra directory, you just drop in your Terraform script. So it's pretty flexible. And to me, AZD up is equivalent to like the .NET run. So that's all pretty cool. So hopefully that was a helpful demo. I would suggest that you give it a try, because all the steps here that I just did, the .NET new Aspire starter, I mean, you can do all that yourself. So
that sounds great, Paul.
That's
And,
really cool.
some people asking here if they can do locally. Yes, they can. They can run all these things just in locally. You can play with .NET Aspire locally, like you just did, like .NET New.
Mm-hmm.
And you don't need a subscription on Azure at the moment. Just play with Aspire first.
Yeah, with Aspire, you definitely can just do it all locally. But if you want to deploy into Azure, this is what I followed. So just go to the main Aspire documentation, scroll all the way down to deployment, and then Azure, and then boom, here we go.
Yep. That's the standard. Aspire itself is cloud agnostic. So you can you can run the Aspire in your local machine, definitely. Then you can actually deploy that into any cloud vendors, including Azure, AWS, something else. But for now, we have the cloud agnostic bits and pieces and Azure deployment pieces. So if the AWS provide us with the package for deploying to their environment, then that will come to their real.
And if you want to go deeper on Azure Container Apps and Azure Kubernetes Service, we have also VS Code, Visual Studio Code extensions, and you can install the extension for Container Apps and Azure Kubernetes Service. It's going to help a little bit. There is a Kubernetes extension, and there is another one called Azure Kubernetes Service extension. You can play with both. And that will also help you to deploy from there. It's just different approach. And I think AZ Dev is trying to simplify that deployment for the first time that you're trying to deploy something.
Yeah.
But I like the synthesized, way you can extract all the bicep files, because that would be very important for the day two operations.
Yeah, I thought that was cool because if you need to make like a slight change to your infrastructure, it's all in code. Yeah, and that's kind of like how I do all my deployments. I'm never in the portal clicking around. It's all infrastructure as code. So
and currently we have a few sets of the component for the Aspire orchestration, but more components will be coming soon, including like the Azure OpenAI service or like RabbitMQ, and we have a RabbitMQ, but something else, some other cloud native the component as well.
Yeah, for the old .NET developers watching these, if you are like from early 2000s, you're going to remember Enterprise Library, where you bring in some kind of guidelines for identity, for caching. I think Aspire is kind of bringing these for the cloud native and simplify with all these connections and pretty much creating like a library for those shared components.
Yeah.
And I had some people just ask me feedback from the community saying, are we doing kind of building these ourselves manually already? And they can probably now move, to use Aspire, and they don't have to write all this code themselves. I think that's great.
That's great. So I think we are let's something summarize and then let's the quick wrap up for this session. So we have introduced what .NET Aspire is, and I have shown a few the demos how to build basically the .NET application for front end and back end application, add orchestration, .NET Aspire orchestration, add Redis cache or something like that, and then deploy this app into the Azure. Then Jorge introduced the concept of Azure Container Apps and Azure Kubernetes Service, and how we can make use of these things for your cloud native application development and deployment. And the last part is Paul did awesome demo using the Azure Development CLI to deploy our .NET Aspire application to Azure Container Apps, as well as how to use Azure Developer CLI with the Azure Kubernetes service using something like even in Bicep and Terraform as well. So I think we have provided all the bunch of informations using how to build your cloud native applications with .NET Aspire and Azure Development CLI and Kubernetes and Container Apps, something like that. So we have some resources for you to share. So the .NET Aspire document you will be able to see there, aka.ms/hacktogether/aspire. And in their cloud native application, that I think the monitoring is tracing is the kind of crucial. So we put open telemetry document as well. So opentelemetry.io/docs. You can start from there. And Azure Container Apps. So aka.ms/hacktogether/ACA. And finally, Azure Kubernetes Service. So aka.ms/hacktogether/AKS. So that's all. You can start from these resources there. Right. So I think that's it for our session. So how was everything, Jorge and Paul?
I really enjoyed. Thank you so much for inviting me, Justin.
Yeah, it's a pleasure being on with you both. And it was equally a pleasure coming back to .NET.
Nice.
and seeing because it's been a while. Like it's been a couple of years since I've been in a .NET project. So,
and people are talking about my background. You see that? You see the Azure there? I used to be MVP. And my famous Back to the Future background.
Love that movie.
I have nothing on my back yet, but I used to have something there, but I just cleaned up. But anyway, so thanks for having me, and thanks for joining this session. So I really appreciate your the talking about like how cloud native application comes into the .NET landscape. So I really appreciate it.
Awesome.
Thank you.
Thank you, everybody.
Thanks, everyone.
Thank you.